In this video, we're going to be finding the limit of a rational function using even more tricky factoring than the factoring we used in the previous videos. So the limit we're going to be finding in this video is the limit as x tends to 1 of x to the 1/6 minus 1 divided by x to the 1/4 minus 1. And again, as in all videos, you'll look first to see if you can quickly get an answer by seeing what happens to each of these terms as x gets close to 1. As x gets close to 1, x to the 1/6, x to the 1/6 gets close to 1. Take off 1, you have 0. And as x gets close to 1, x to the 1/4 gets close to 1 as well, because that's the fourth root of 1. So you get a 0 over 0 indeterminate form here. And of course, to get around this indeterminate form, we are going to have to do some algebra. And if the title of this video didn't already hint this to you, we are going to be using some factoring. Now, looking at these, they don't seem to fit any of the a squared plus 2ab plus b squared, or a squared minus b squared, or a cubed minus b cubed, or a cubed plus b cubed forms that we're familiar with. Or do they? Well, x to the 1/6. X to the 1/6, let's first look at that. X to the 1/6, it can be re-expressed a bunch of different ways. One way is as x to the 1/12 squared. So this is x to the 1/6. But it can also be rewritten as, just write it again here, as x to the 1/18 cubed. It can also be rewritten as x to the 1 over 24 raised to the power of 4. Because remember, when you take something that's raised to a power and raise that entire quantity to another power, that's in effect multiplying the power that you first raised it to by the power that you're raising everything to. So 2 times 1/12 is 1/6. 3 times 1/18 is also 1/6. But so is 4 times 1/24. So this numerator here, if we just look at it alone, x to the 1/6 minus 1, it can be thought of as, and it's equivalent to, x to the 1/12 squared minus 1 squared. But it's also equivalent to x to the 1/18 cubed minus 1 cubed. But it's also equivalent to x to the 1/24 raised to the 4th power minus 1 raised to the 4th power. Now this denominator here, x to the 1/4 minus 1, so x to the 1/4, well, let's first look at x to the 1/4. It can be re-expressed as x to the 1/8 squared. It can also be rewritten as x to the 1/12 cubed. And finally, it can be rewritten as x to the 1/16 to the 4th. And there are actually infinitely many number forms it can be rewritten as, like x to the 20th to the 5th, and so on and so forth. If we use this form of x to the 4th, then x to the 4th minus 1 we wanted to express x to the fourth minus 1 as the difference of perfect squares, we'd say that's x to the 1/8 squared minus 1 squared. If we wanted to express it as the difference of perfect cubes, we'd say it's x to the 1/12 cubed minus 1 cubed. And if we wanted to express it as the difference of things raised to the fourth power, I don't know whether there's a term for things raised to the fourth power, like you have squares and cubes for second and third powers, but be x to the 1/16 raised to the fourth minus 1 to the fourth. So those are a bunch of different ways of writing the numerator. We have 3 different ways shown here and 3 different ways of writing the denominator. And each of these ways results in something that's factorable. Here we have something of the form a squared minus b squared, where a is x to the 1/12 and b is 1. Here we have something of the form a cubed minus b cubed. Here we have something of the form a to the fourth minus b to the fourth. And for the denominator, it's x to the 1/8 squared minus 1 squared is of the form a squared minus b squared. X to the 1/4 minus 1, or x to the 1/12 cubed minus 1 cubed is of the form a cubed minus b cubed. And x to the 1/16 to the fourth minus 1 to the fourth is of the form a to the fourth minus b to the fourth. So we have a bunch of stuff written down here, a bunch of forms written down, but which one is going to be useful for this problem? I will pick a form. I will show you the one that ends up being advantageous in this particular case, and then show you why that is. So I'm going to rewrite the limit we are trying to find up here. That's the limit as x tends to 1 of x to the 1/6 minus 1 divided by x to the 1/4 minus 1. And I'm going to rewrite this numerator as x to the 1/12 squared minus 1 squared. And that's just x to the 1/12 squared is x to the 1/12 times 2, and 1/12 times 2 is 1/6. I'm going to rewrite this denominator as x to the 1/12 cubed. So x minus 1 cubed. So x to the 1/12 cubed is x to the 1/12 times 3. So, and it's 1/12 that's being multiplied by 3. So that would be x to the 1/12 times x to the 1/12 times x to the 1/12, or x times 3 to the 1/12, which is x to the 1/4. And if we write the numerator and denominator in these particular fashions here, when we write it in this particular fashion, we'll see what happens when we factor. So this is of the form a squared minus b squared. When you factor that, you get a plus b times a minus b. So a squared minus b squared equals a plus b times a minus b. A here is x to the 1/12, and b here is 1. So x to the 1/12 plus 1 times x to the 1/12 minus 1. Okay, this is, we're taking the limit as x tends to 1. Limit as x tends to 1. The denominator, we have the form a cubed minus b cubed. And that is a minus b times a squared plus ab plus b squared. And I've gone over this in other videos, but if you don't believe me, you can expand this expression here, and you'll see that all terms but the a cubed and b cubed terms drop out. So what you have here is a minus b, which is x to the 1/12 minus 1 times a squared. So that is going to be x to the 1/12 squared plus a times b. So plus x to the 1/12 times 1, and then plus b squared, so plus 1 squared. And what you'll notice here is that this x to the 1/12 minus 1 term cancels with this x to the 1/12 minus 1 term. And it was this something minus 1 over something minus 1 that was giving us that indeterminate form. Because as x tends to 1, x raised to any power, whether fractional, negative, or anything, results in something that's 1, right? And you subtract 1 from 1, you get 0. And so x to the 1/12, when 1's raised to the 1/12, or as x gets close to 1, x to the 1/12 gets close to 1, you subtract 1, you get 0, and that same issue is present here in the denominator. This cancellation here allows us to get around that 0 divided by 0. And if we go ahead and evaluate this limit here, looking at the numerator, so I'll just write it more clearly. Limit as x tends to 1, x to the 1/12 plus 1 in the numerator. The denominator we have x to the 1/12 squared plus x to the 1/12 times 1, which is just x to the 1/12, plus 1 squared, which is just 1. And that's the limit as x tends to 1 of x to the 1/12 plus 1. Denominator, this x to the 1/12 squared is x to the 1/6. Okay, 1/12 times 2 is 1/6. Oh, oops, I wrote 1/16, so it should be x to the 1/6. Ignore that there. Plus x to the 1/12 plus 1. And if we find this limit, okay, as x gets really close to 1, well, its 12th root, what's the 12th root of 1? X to the 1/12 is the same thing as the 12th root of 1. And that's 1 because that's the same thing. Because that asking what x to the 1/12 is the same thing as asking what do you have to multiply 12 times to get 1? Well, if you multiply 1 by itself 12 times, you will still get 1. So this is 1 plus 1. And this is asking x to the 1/6. What multiplied by itself 6 times gives you 1? Well, 1 multiplied by itself 6 times gives you 1, right? 1 plus 1. 1 times 1 times 1 times 1 times 1 times 1. Hopefully I said that 6 times. And the same deal here. X to the 1/12 is 1. And then we have 1 here. So 2 divided by 3 is 2/3. Now, as for why we made these selections that we did, why did we choose to re-express this numerator as x to the 1/12 squared minus 1 squared instead of, say, x to the 1/18 cubed minus 1 cubed? Well, we wanted to somehow get rid of this x to the something minus 1, because when x tends to 1, x to anything raised to any power, will also get close to 1. So we wanted to re-express this in a way so that when both the numerator and denominator were factored, one of their factors would cancel. And looking at this, you saw that 12 is a common multiple of 6 and 4. So if we look at this x to the 1/6 as the square of x to the 1/12, and we look at this x to the 1/4 as the cube of x to the 1/12, we can get an x to the 1/12 minus 1 factor in both the numerator and denominator. They can subsequently cancel, leaving us with no terms of the form x to the something minus 1. See, what we're left with here are only plus signs, right? So we're good. We don't have to deal with x to something minus 1. And we can go ahead and evaluate the limit. And when we do so, we get 2/3. Hopefully that sheds some light into why we picked these particular forms of the numerator and denominator respectively.